What is up, car and tech fans? Welcome back to another garage tinkering video. I'm pretty excited about this video because it's one that's been coming and been promised for quite a long time, because for the first time we finally get our hands on the ESP32-P4 development module from Waveshare. Now, I only received this yesterday, so I haven't been able to really deep dive into it yet, but in this video we're going to look at what it offers, what it's capable of, and then over the next few weeks, we're going to be building some insanely cool digital dashboards that utilize this thing. And before we get into the full breakdown, let me just address the slightly small elephant in the room. Yes, I have a big old scar on my head. Whilst finishing putting my 350Z back together over the last few days, the pole that was holding my boot open slipped, and the boot slammed down on the back of my head, hit my face into the rear frame of the car, and cut me up something good. So yeah, hopefully that disappears soon enough. But more importantly, let's go take a look at this board and see what it offers and why everyone is so excited about it. The first thing you're obviously going to notice on the board is the absolutely massive MCU sat in the middle of it. This is the P4, our colossal powerhouse, but it's worth noting, due to some decisions that have been made by Espressif with the creation of this chip, that it isn't just a P4, because the P4 does have some limitations that we're going to look at. This is a P4 and a C6, which work in collaboration to bring all of the functionality to the board that you may want. So the P4 has separate high power and low power cores. The high powered is a RISC-V 32-bit dual core, which can run up to 400 megahertz, whereas the low power is a RISC-V 32-bit single core that runs up to 40 megahertz, which is great if you want to be able to run things in very low power mode and still have a decent amount of performance available. To compare how much of a step that is, we use on this channel very often the ESP32-S3, in particular this LCD driver board from Waveshare, and this thing maxes out at 240 megahertz. So 400 is obviously a huge capability step in that regard. But what about memory? How much of that did we have? In the S3, we got 512K of SRAM, 384K ROM, 8 meg PSRAM, and 8 meg flash memory. In fact, in this one, it was 8 and 8. Sometimes they're 8 and 16. On the P4, again, it's split into high and low power. We now have 768K of L2 memory for the high performance system and a separate 32K of SRAM for the low power, combined with 128K of high performance ROM and 16K of low power ROM. But then, this is where things get really good, the PS RAM, which is what we utilize in all our projects all the time, has increased from 8 meg on the S3 through to 32 meg on the P4. This thing packs a punch, 4 times the amount of PS RAM available. Plus it has 16 meg NOR flash memory on it as well. It's just a beast, which is shown by what it's actually capable of, which I'm looking forward to showing you in a minute. The chip itself has an absolute mass of programmable GPIOs. In fact, it's got 55 available, which is, again, a huge step up from anything before it, and includes all of the things that you would expect on a chip like this for peripherals. You've got your SPI, your I2S, your I2C, LED PWM, MC PWM, RMT, ADC, UART, and TWAI, and lots of other initialisms and acronyms that are available. I could just spurt them all out. I'm just guessing that if you're watching a video about a microchip, you're probably going to understand what they all mean. So there's just loads of options for good high-speed connectivity. Now, I did say that the P4 does have an issue, and the issue is that for whatever reason, Espressif has decided to remove Bluetooth and Wi-Fi connectivity from the chip itself. So if you want to have those things, you can't, except you kind of can. Because like I said, this chip is bundled both as a P4, but also a C6, which can communicate with each other in serial. So if you want to use Bluetooth and Wi-Fi, and we use ESP-NOW a lot in our applications, then we can set that up and send that information directly to the C6, which then will work in serial with the P4 and transfer that information across. So it's a little bit of a kind of a workaround, and I guess that there are going to be advantages for that. If you're somebody who doesn't need to use Bluetooth and Wi-Fi, you kind of remove that responsibility from that chip and allow it to focus on the thing that it needs to focus on. But yeah, it's an interesting decision. It's going to be interesting to see how that plays out when we're actually building applications on it. But by using that C6 as a co-processor, we do get access to Wi-Fi 6 and Bluetooth 5. But obviously this board is about a lot more than just a processor. There's a bunch of other periphery connections that we've got available. There's 2 sets of 20 header pins, which give us 28 programmable GPIOs, which should be more than enough for anything we're going to need to make. We've got the 4 onboard Type A USB 2 with the OTG interface. There's the 100 meg Ethernet interface. On the back, we've got an SDIO3 TF card slot, and obviously your standard USB and Type-C UART flashing points. There's a bunch of inputs and outputs for common things. Onboard speaker interface, there's a microphone, and it comes with a codec chip and an amplifier, which can be used to really work with that sound and make sure that you can get quality sound coming from the board. But the thing that is big for me, and the thing that's going to, I think, revolutionize what we're able to do with dashboard design, and the reason I'm so excited about getting this board, is the 2 little inputs at the bottom, the MIPI input and output, which allow us to output a full 1080p at 30 FPS. That's batty coming from a processor this size. To put that into context, I've seen videos where people are able to play Quake on this thing. Not Doom. I know Doom is the standard, get it to play on anything, but Quake, like a whole extra step more difficult. I think that this is going to be able to handle some animated dashboards pretty easily. Alongside that MIPI output, we have a second MIPI in, which is used for a camera, which can also capture at 1080p 30 FPS. And it has a fast enough pixel processing accelerator to be able to live input that 1080 signal and output it straight away. So when we come to make our own reversing cameras, parking cameras, dash cams, we're going to be able to move away from having to use kind of like any pre-made systems. We're going to be able to integrate and make a whole new system. Imagine this, we flick into reverse and the 3 screens on my 350Z, the middle one becomes the reverse camera, live feed. The 2 on the side become side cameras, live feed. I'm never going to scrape my wheels ever again. This is going to be huge, and I cannot wait to build this stuff over the next few months. So enough talking about numbers and things that, you know, for the layman might not really mean anything. Let's see what this thing's actually capable of. Unfortunately, Waveshare also sent me a couple of their screens to test this with. We've got a 7-inch and a 10-inch DSI LCD. Other than the size, these things come much the same. We get a speaker, the 2-pin power cable, some FFC 22-pin cables, and a DSI cable. So as well as some screws and some standoffs so we can put all this thing together. This is the 7-inch screen, which we're going to be using in a future project to do kind of like a cool entertainment car controller, LED colors, animations for the cars. Some really cool stuff, but that's going to come a little bit down the line. So for now, let's just use the larger 10-inch display. And this is how it is when you set it up. It comes with the mounting points on the back where you can put one of your P4 dead modules, and then we just connect it up to the screen with the DSI cable and the 2-pin cable. We've also got the speaker attached, just in case there's anything on the example firmware that makes noise. I don't know. plug this thing in. USB. And here we go, starting up. And we have liftoff. So what have we got? Nothing on the other screens, but these are some, I guess, some example applications. Wi-Fi, is it going to scan find my Wi-Fi? Yes. FreddyNet, named after my dog. It's my Wi-Fi. I guess I could connect to that. I'm not going to, but it shows that this is working fine. What other settings do we have? Oh, is it just Wi-Fi? Just Wi-Fi. Calculator is probably quite a simple one. Yeah, 100 times 90. Yeah. Calculator, all good. Draw panel, I guess, is just going to... Okay, we can draw. Hi. You can clearly see the steps in this. Like, I guess if we go quite quickly. Yeah, so it's... What it's doing is it's calculating the position every X amount of time. So if you go slowly, you get a smoother line. It's just, you know, it's just a programmatic choice. It's not indicative of the performance of this thing. It is running decently quick. We have a music player. What's in here? Is this going to demo from here? Oh, God. Look at that. Nice. Yep. As you can see, with the fluidity of this animation that's moving around the outside, I don't think this is going to have any issues at all doing a few LVGL graphs. I think it's going to make absolute mincemeat of them, to be honest. Bit fur-elise, very nice. So yeah, music, what's this? All tracks. Do I have to swipe? Oh yeah, okay. No. And it doesn't stop when you go back. So how do you... There we go. Stop. We have the camera, but I don't have a camera plugged in for this at the moment, so that's not going to do anything. So we'll ignore that. The 2048 game is, yeah, a game. Oh, lots of noises. Works very nice and smoothly. Also, I'm a genius. So that's all, yeah, nice and smooth. And then I guess Squareline Studios. What is going to be in here? Smart gadget demo. Okay, so these are some, yeah, other things, other LVGL demonstrations, because this whole thing is made using LVGL. Weather, not sure about the UI design on this, but partly cloudy in New York. More music stuff. This one doesn't do anything. No. Some text. Let's get some dinner. How about pizza? Sounds good. What about James? He likes it too. Why do we meet? Conversational genius. Oh, Elena Smith Bergman is calling me. I can't answer. Sorry, Elena. But again, I guess this is just another little demonstration of what is possible using LVGL. That's annoying. Let alone that. Come on, guys. And does any of this at the top do anything? No, no swiping, no. App change, maybe? Oh, yeah. Oh, okay. We've got a sort of performance monitor. We're using, yeah, a very small amount of the available system resources in here. But we can see this all moves nice, it's smooth, it's clear. it's not an overly resourceful demonstration, and it obviously doesn't encapsulate lots and lots of the capabilities of the chip, but it shows that LVGL, which we use pretty much exclusively in order to make digital dashboards and gauges and stuff on this channel, runs on it very, very easily, very, very smoothly. I honestly think it's going to be way more processing, way more memory, way more power across the board than we're going to really need, which is great, because I'd rather have a lot of headroom and know that I'm not going to use it than risk getting near my 100% CPU or 100% memory usage. It's a problem we often come across when we're making gauges using the S3, because when we bring in something like ESP-NOW that runs on one of the cores of the S3 and then LVGL, which runs on the other, it obliterates the performance and it maxes out the CPU, which means that it's prone to getting panic resets and restarting, which is not something you're going to want, especially in an automotive environment when you're, say, relying on one of the screens to have your speed on it. It's not something that you want to ever have fail. So I'd rather have lots and lots and lots of overhead for the complex things like, multiple screens or video feeds or animations, all this kind of cool stuff that we're going to be building over the next couple of months utilizing these development boards, than risk getting anywhere near the potential of the MCU and the boards that we're using. So that's like my first hands-on with this. I think this is going to be a game changer. This is going to mean that we're able to create new things for the cars that we're going to be working on over the course of this year and beyond that we simply couldn't have done without having this level of potential available to us. The fact that it's got onboard CAN, the fact that it can do full 1080, the fact that it can do video, the fact, perhaps controversially, that it takes the Bluetooth and the Wi-Fi away from the P4 onto a separate C6 means that it can do a separation of concerns, and the C6 just worries about, our ESP-NOW, our incoming data, and the P4 can just worry about rendering and making sure the screens work and are updating really quickly without any performance issues. I think an interesting question though is this going to kill the S3 when it comes to dashboard and gauge design? And I think yes and no, but probably mainly no, because little screens, 2.1 inch screens that we utilize a lot on this channel, are still going to be a small enough screen that a S3 is more than capable of doing what you want, especially if you're doing things like removing ESP-NOW and just using direct CAN. In fact, this little box from PCBWay has just arrived whilst I'm recording this video, and in here are my new custom PCBs for my 2.1 inch screens that use an S3. The cellophane is still on. I literally haven't opened this box yet. This is next week's video. I'm really hoping that these work. But I think the S3 is still going to be perfectly good and probably the better choice, at least for the short term, for creating small individual gauges. Large dashboards, though, I'm going to be using two 3.5 inch round displays, which are about 800 by 800, and a 4 inch that's about the same again. So 3 big screens. I think the P4 is not only going to be necessary because an S3 can't power screens of that size, but we're going to require that level of capability in order to fulfill the range of requirements that we're going to want from these screens. There are 2 other small considerations that you need to have if you're considering using this P4. First off, right now, at time of publishing this video, which is going to be the 9th of April, 2025, it only supports development on ESP IDF. So if you favor using Arduino IDE or Platformio, right now, all of the capabilities aren't available on it. Now, most of the functionality has been migrated to Arduino Core 3.1.1. So if you want to use that, you can. I haven't dug into any of this code yet. That's something for the next couple of weeks. But that migration doesn't include, as of yet, MIPI support. So no screens. problematic. So it's definitely a consideration if you're not overly familiar with the ESP IDF framework. You're going to have to get to know it, or just wait a little bit, which is the second point and something you might have to do. The P4 and this development module, they've not gone into commercial production. Now, you can find them. Waveshare's boards, for example, do come up and are available. If you want to see if they happen to be available right now, there are some links in the comments. But because they are pre-release and right now they're predominantly going to people like me, they are selling out very, very, very quickly. So if you do want one and you follow the link below and it says that they're in stock, don't hesitate, buy it, because they don't hang around. Once they're available, people buy them all. So yeah, get your hands on them as fast as you can if you see them available on the link below. With that in mind, I do have to say a massive thanks to Waveshare for reaching out and sending me all of this stuff. I cannot wait to get my hands dirty with it over the next few weeks, and I already have plans in mind for some amazing stuff that we're going to be developing. Like the digital dash from my 350Z is going to be an attempt at the redefinition of what a dashboard is. That'll make more sense as we get there. Anyway, that's it for this one. What do you think of the P4? Are you excited to get your hands on one yourself, and what you're going to use it for? If so, it'd be great to know what you think about it. So stick any thoughts in the comments below and we'll be able to have a bit of a conversation about it. Otherwise, if you do want to chat more about this or see what I get up to with it, you can join us over on our Discord. Again, there is a link in the description. Loads of people sharing their projects, and a bunch of people have managed to get their hands on these P4s. So yeah, there's a lot of discussion about how they're going to be utilized and the good and bad points of them. Otherwise, keep your eye out, because in the next couple of weeks, we're going to start building things for the first time with these boards. No one's really doing it yet. So let's carve a way forwards with something really new and cool. Whatever you do with the rest of your day, folks, have a wicked one. I'll see you in the next video next Wednesday at 2 p.m. Take it easy, peeps. Bye-bye.